Now that we know what inverse functions are, we need to find a way to test for inverse functions. And we do have one, and here it is. If you have two inverse functions and you compose them together, so f composed with f inverse, the result of that will just be x. In a similar fashion, if you compose f inverse with f, you'll get x as well. So that's a quick way to test if two functions are inverse functions. So let's do that. Alright, so here in example A, I have f of x equals 3x minus 1 over 5, and g of x equals 5x plus 1 all over 3. The question is, are these inverses? I see a lot of common numbers, but it doesn't really mean anything about them being inverses or not. Alright, so what we want to do then is let's consider f composed with g of x. Now remember what that means is you take the f function and you plug g of x in for all the x's. So what that looks like here then is 3 g of x minus 1 over 5. Okay, from here it might get a little ugly, but I think this is going to work out okay. I have 3 times 5x plus 1 over 3 minus 1 all over 5. Okay, now notice here the 3's cancel. When I cancel those out, I end up with 5x plus 1 minus 1 over 5, which is going to be 5x plus 0 over 5. Here the 5's can cancel out, and I end up with simply x. They are inverses. G of x is actually f inverse, and f is actually g inverse. Just for practice, let me show you another one. Okay, so for part B, we have f of x is 1 over 1 plus x, and g of x is 1 minus x over x. Okay, are these inverses is the question. So here we need to just compose them. And this time, just for fun, I'm going to compose them in the reverse order, which means I'm going to take the g function and plug f in anytime I see an x, which looks like 1 minus f of x over f of x. Okay, now this could get ugly. Alright, so let's see what we get. That's going to be 1 minus 1 over 1 plus x all over 1 over 1 plus x. So because of that, in the numerator here, I need to get a common denominator. The 1 is the same as 1 plus x over 1 plus x. Then we have minus 1 over 1 plus x. All that over 1 over 1 plus x, this looks like it's going nowhere. But notice in my numerator here, now that I have a common denominator, I can bring them together. And when I do that, and I'll write this in that pink color, I have 1, in the numerator of the numerator, I have a 1 plus x minus 1, which ends up being an x over 1 plus x. That's my numerator, all over 1 over 1 plus x. Okay, now I remember that dividing is the same as multiplying by its reciprocal. Dividing by this 1 over 1 plus x is actually the same as multiplying by its reciprocal. So I have x over 1 plus x times the reciprocal of that denominator. And now notice those two cancel, and what's my result? After all the dust settles, I end up with x. I compose these two functions and end up with x. If you could see me, I'm waving my hands in the air. What this means then is that they are inverses. This is kind of the caboose on the topic of inverse functions in algebra. We've seen what a one-to-one function is. We've seen how to find inverse functions. And now we see how to test if two functions have an inverse relationship through composition. I hope this makes sense. If you have any questions on it, I'd be glad to help. And thank you for watching.